Okay, so now we're going to talk about how to solve linear inequalities. And I'm not going to graph the solutions here, but you need to just make sure you know how to graph the solutions. If you covered the section that I just made, then it gives you a lot of examples on how to graph these solutions on the number line. Okay, now one thing I do want to mention here, that when you're solving inequalities, you can pretty much use the same rules you did when you were solving equations. For instance, if you want to, if you have an inequality, you can add the same number to both sides and the inequality will still hold true. You can subtract the same number from both sides and the inequality will still hold true. You can multiply both sides by a positive number or divide both sides by a positive number and the inequality still holds true. But one thing you have to remember is if you multiply both sides by a negative number or divide both sides by a negative number in an inequality, it forces the inequality to reverse direction. I like to show my students a simple example of that they can understand. Okay, so here's an example. And notice that I think it's obvious to us that negative 3 is certainly less than 2. But let's see what happens if I multiply both of these numbers by a negative value. Let's say I multiply both these numbers by negative 1. So let's say I multiply negative 3 by negative 1. And of course you get a positive 3. And then let's say I multiply 2 by negative 1. And that'll give you a negative 2. Okay, so now the question holds. Okay, so now how are these related? Is the left side still less than the right side? And I think you can see that that's not the case. So the inequality actually has to be flipped over and made greater than. So that's true whether I multiply both sides of this inequality by a negative number or whether I divide both sides of this inequality by a negative number, then the inequality has to change direction. Okay, and we're going to see that on the first example here. Okay, so for instance right here, if I want to solve 3 minus 4n is greater than 15, the first thing I'm going to do is subtract 3 from both sides. And I just did that in my head. So if you subtract 3 from the left, it's just going to cancel the 3. And then 15 minus 3 is going to give you 12. So some of these steps I'll do in my head. Okay, now, negative 4n is greater than 12. So to actually solve this for n, to isolate the n, I actually need to divide both sides by negative 4. Now what did I just tell you? When you divide both sides of an inequality by a negative number, what did I just tell you was going to happen? Notice the inequality has flipped over. So now the result, negative 4n divided by negative 4, that's just n, and it's going to be less than 12 divided by negative 4, which is negative 3. So n is less than negative 3, and if you write that in interval notation, it's just negative infinity to negative 3. Okay, now this one, here on this one, I can add 1 to both sides. So if I add 1 to the left, it'll cancel the negative 1. And then add 1 to 3, you get 4. So I get 2x is less than 4. Now here, I just did this in my head where I divided both sides by 2. So if you divide both sides by 2, and since 2 is a positive number, it's not going to change the inequality. So 2x divided by 2 is x, and 4 divided by 2 is 2. So this is just x is less than 2. And that would be, in interval notation, that would be negative infinity to 2. Now, you start getting into some of these multi-step problems now. So here I have 3z plus 2 times z minus 1 is less than 4. So first thing I'm going to do is distribute the 2, and I know that 2 times z is 2z, and 2 times minus 1 is minus 2. Now, I want to combine the like terms on the left of the inequality. So I have 3z plus 2z, which is 5z, and then the minus 2 just comes on down. So now I have 5z minus 2 is less than 4. Okay, so now I want to get the 5z isolated by itself. So you can just add 2 to both sides. So add 2 to both sides there, and then you'll get the minus 2 and the plus 2 cancels, and you'll get 6 on the right side. So I have 5z is less than 6. And then all I have to do now is divide both sides by 5. If I can write that for you, that's ugly. But anyway, I'm dividing both sides by 5. So anyway, when I divide 5z by 5, I get z, and then 6 divided by 5 is 6/5. And then so z is less than 6/5. And in interval notation, that would be negative infinity, comma, 6/5 with parentheses. Okay, here's another one. Now notice here, my inequality is greater than or equal to. So let's keep an eye on that as we work this. So now, what I'm going to do now is I'm going to subtract 2x from both sides. So if I subtract 2x from both sides, it'll cancel that from here, right? And then move the 2x over here, make it a minus 2x. I'm also going to add 5 to both sides. So if I add 5 here, it'll cancel this, and then I'll add 5 to 3 and get 3 plus 5. So now 4x minus 2x is 2x, and 3 plus 5 is 8. So I get 2x is greater than or equal to 8, and then you can just divide both sides by 2, and 2x divided by 2 is x, 8 divided by 2 is 4, and since we divided by a positive number, it's not going to monkey with the inequality at all. So now the solution is x is greater than or equal to 4. Now since it's greater than or equal to 4, notice I put the bracket with the 4 to show you that the 4 is included. And then of course it goes out to infinity. Okay, now they get a little bit more difficult here. Right here I have n plus 3 plus 7 times 8 minus 8n is less than 5n plus 7. So the first thing I'm going to do is distribute again. 7 times 8 is 56, and then 7 times negative 8n is negative 56n. Then let me collect like terms. You have 1n minus 56n, so that's going to give me minus 55n. And then I have 3 plus 56, that's going to give me 59. So I have 59 minus 55n is less than 5n plus 7. Now I can subtract the 5n from both sides, so that'll give me minus 55n minus 50n, and it'll cancel the 5n when I subtract 5n from both sides. And then I can subtract 59 from both sides, so that the 59 is gone from here, and then over here that'll give me 7 minus 59. Okay, so that's going to be negative 55n minus 5n, that's negative 60n, and then that's less than 7 minus 59 is negative 52. So I have negative 60n is less than negative 52. Now, here's where you got to be careful. I have to divide both sides by negative 60, right? To get n by itself, I got to divide both sides by negative 60. Okay, so when I divide, since I'm dividing both sides of the inequality by a negative, notice that the inequality flips over and it becomes a greater than. So I actually end up with n is greater than, and remember if you divide negative 52 by negative 60, a negative divided by negative is positive, so it's the same as positive 52 over 60. And then in the last step I reduce this fraction. If you divide the top and bottom by 4, 4 goes into 52 13 times, and 4 goes into 60 15 times. So I finally get n is greater than 13/15. And then interval notation will be 13/15 to infinity. And then on this one, I'm going to distribute the 2. So 2 times 3z is 6z. 2 times minus 2 is minus 4. Over here I'm going to distribute the 4. 4 times 2z is 8z. 4 times 5 is 20. Okay, so now what I want to do is I want to combine like terms. So I have z plus 6z, that gives me 7z minus 4 is less than or equal to 8z plus 20. Now I'm going to subtract 8z from both sides, and when I do, it'll cancel this 8z and it'll move a minus 8z on the left. Then I'm going to add 4 to both sides, and when I add 4 to this side, it's going to cancel the negative 4 and just give me 20 plus 4 on the right. Well, 7z minus 8z is negative z, so I get negative z is less than or equal to 24. Now, to solve this, I can multiply both sides by negative 1, right? Well, if you multiply both sides by -1, then what's going to happen? Since I'm multiplying the inequality on both sides by a negative number, it's going to flip that inequality over from a less than or equal to a greater than or equal to. So my solution is actually going to be z is greater than or equal to -24. And since it includes the -24, I do a bracket -24 comma infinity for the interval notation solution. Okay, so I wanted to do a couple of problems here that involve fractions. So if you look at this, I get minus m over 6 is less than or equal to 3/4. So what I did first is I thought, okay, what will 6 and 4 both go into? 6 and 4 will both go into 24. I should have used 12. I'll admit I should have used 12. But 24 will work. But 12 would have been better. But anyway, 24. So I multiplied both sides by 24. So multiply this by 24, and you can see that 6 goes into 24 4 times. And so I have negative m times 4, which is negative 4m. And then over here, 3/4 times 24, 4 goes into 24 6 times. And then I have 3 times 6, which is 18. So I have negative 4m is less than or equal to 18. Now, remember, I have to divide both sides by a negative number here, right? So if you divide negative 4m by negative 4, you get m, right? And then if you divide 18 by negative 4, you get negative 18 over 4. Now, but look at the inequality. Remember, if I have to divide both sides by a negative, then I got to flip this inequality over and make it a greater than or equal to. Now, the last step is simply to reduce the fraction. Negative 18/4 is the same as negative 9/2. So my final answer is m is greater than or equal to negative 9/2. Now, probably if I'd have used 12 up here instead of 24, I wouldn't have had to reduce. It would have just given me the negative 9/2, and I wouldn't have had to reduce it. But still, I get the right answer anyway. And here's the interval notation for m is greater than or equal to negative 9/2. Okay, the last one here, 2 is less than a minus 2 over 5. If I multiply both sides by 5, it'll get rid of this denominator. So multiply 2 by 5, and I get 10. Multiply this by 5, and the denominators just cancel, and I get a minus 2. Now, I'm going to do something a little bit tricky here. You see how that's a minus 2? I'm going to read it right to left. Read it right to left. So that says a minus 2 is greater than 10. Okay, so let me write it like that. A minus 2 is greater than 10. And I actually wrote it wrong here, didn't I? A minus 2 is greater than 10. All right, now add 2 to both sides, and you get a is greater than 12. So I got that one wrong. Shame on me. Okay, so a is greater than 12. So the interval notation would be from 12 to infinity. Okay? So anyway, that pretty much completes this section on solving linear inequalities. Now I've got another section I want to show you that involves solving those compound inequalities. So we'll do that next. We'll do that section next.